Hello and welcome to another episode of the DigiTeacher Digest. This week I'd like to talk about computing education, specifically at the kind of middle school but also upper primary school, very appropriate. And we've been looking at different cognitive tools over the last couple of weeks. And I'd like to look at some of the cognitive tools that are used in computer education. These are tools specifically designed to help to teach students how to code. So the first pedagogy that I'd like to look at is called PRIM, which stands for Predict, Run, Investigate, Modify, and Make. This is a pedagogy used a lot in computer education in primary schools, middle schools, and it's designed to try and move a student up the proximal zones of development. So from what they can do at a stretch to be able to become more comfortable at doing it. And the aim here is not to throw them in the deep end. So you don't ask them, here's a problem, solve it by using code. And you don't say to them, design some code to do this. What you do is you give them some code. And the code is something which is starter code. It needs some tweaking, it needs some changing to do the job that you want it to do. And you get the students to look at the code and, first of all, predict what it is that they think the code will do. So you get them in groups, 2s or 3s, to discuss this, and it allows them to read the code, to try to understand what the code is doing, and it deepens a knowledge of the programming concepts. So for example, if the code has a nested conditional, then they need to engage with that and kind of figure out how exactly is this working. And that builds their confidence in being able to handle what are fairly difficult concepts at this level. So once they've predicted what they think will happen, they run the code to see if their prediction is correct. And then obviously they have to modify their prediction if it doesn't quite work out. And again, they get an opportunity to discuss this and work through what it is that the code was actually doing. They then investigate how to tweak the code, how to change the code to make it their own. So you need to look at, well, if, for example, the robot is making a square, well, how would you make a circle, for example? How would you tweak it to do that job? And then they get to modify the code. So here they get to actually change the code and then thus making it their own. So I think this particular pedagogy is very useful in helping students and scaffolding those kind of early learning, especially if you're moving between block code, for example, and text-based coding. That's quite a jump to make, quite a leap. And just to sort of suddenly move to start typing in command line, type code. And if you give starter code that then just needs tweaking, I think it helps that process a great deal. This particular cognitive tool was designed to be used in coding classes, computer programming, but I think it has applications in other subjects as well. For example, it strikes me that in teaching writing, you can take a piece of writing and get students to in effect run through it, to investigate what they feel the weaknesses of that piece of writing is. Maybe it's not reaching its intended target audience. Maybe it needs a more persuasive tone, stuff like that. Or that its argument is not adequate, that it's not being supported with enough facts or examples, anecdotes, and so on. You can then get students to improve on the piece of writing and make it their own. I think there's a lot to be learned from following this kind of basic predict, run, investigate, modify, make procedure. The next pedagogy I'd like to look at is called SPOT in the literature, but I like to use something I call SPOTI, S-P-O-T-I. And the whole idea here is to take the proximal zones of development and to teach students to start with themselves and try and tackle a problem themselves before escalating it to other people. So this is basically how it works. The S in SPOTI stands for self. So the whole idea here is that you need to wrestle with a problem for a certain length of time yourself before you involve anyone else. You can't just throw up your hands and say, I don't understand, let me ask someone else before you have tried yourself. And this is something in a coding class very often kids will do. They will hit a problem and they won't even try to tackle it themselves. Now you can work in peer groups, and this obviously helps, and you could start with a peer group. But sometimes at a certain level, you want people to start to become more independent and to start with themselves. So I think at middle school level, it's a good idea to have individual tasks where they are working on the task and have to try at least to tackle the problem themselves first. So that's the S, the self. Then you've got P, and P is for peer. Now, peer is someone else, the person sitting next to you. And I like to form my classes up in kind of peer groups so that as they sit around the table, they're working with someone else around the table. So that would be the P, peer, that if you can't deal with something yourself, you turn to someone else and say, hang on, what's going on here? What do you think? Do you have any ideas? I can't manage on my own. And you try and encourage this kind of behavior. Two heads are better than one, and when kids are talking about it, they are learning about something. The O in Spotty stands for other. So the other would be the wider classroom, not just your peer, but the other people sitting at your group table, for example, or the classroom as a whole. If you and your friend can't sort out a problem, then you can ask the wider class. Say, has anyone managed to do this? And I like to build that in as part of the procedure. That after you have tried something, after you've tried it with your friend, your peer, then you can turn to the class as a whole. And you can particularly use mentors in this instance, people who are ahead in the task, who for whatever reason are managing to solve the tasks a little bit faster. You can get them to become official mentors. And then it is their responsibility to go and help other people who are struggling. Then, of course, there's the T for teacher. So I don't like to answer questions straight away. I want my classes to engage with something and struggle with something before I come up with a solution. But obviously there reaches a point where if no one in the class is getting something, you need to step in and at least give them a hint as to where they need to go. So we've had the self, we've had the peer, we've had the other, now we have the teacher. And in the literature it kind of stops here, but I like to add another level, a fifth level, the internet. So if there is something that I can't do, something that I don't know, and very often I will feign ignorance. So even though I know the answer, I want to show students that computing is something which changes so rapidly that not everybody knows everything or can know everything. So obviously if I don't know, we Google it. So quite consciously in front of the students, I will, on an interactive whiteboard, I will Google a problem. We'll stand together looking at the solutions and trying to figure out how to do it, through internet help. And as I say, sometimes even if I do know the answer, it's quite a good idea to take students through this process, especially if it hasn't happened in a while. I think, in every couple of weeks, you should see the teacher modeling, finding out answers to reinforce the idea that not everybody knows everything and that everybody needs to find out from other people. This technique, I think, can be used not just in a computer class, but in any classroom as well. And I think it needs to be kind of baked in to help foster the kind of dispositions that you want computer programmers in your class to have. Things which happen on the internet quite naturally, and Stack Overflow and things like that. You need to model that for students. I put some links to further information in the description. If you enjoy the content on this channel, then please like, subscribe, share, and hit the bell. I'll see you next week.